This will be for the con exercise, model with composite functions. All right, let's say you have a composite function, a of b of x. Okay, so this is basically a function within a function. And this variable x is going to be your input variable. And as a result, since x is the input variable, this entire composite function is going to be a function of x. It's dependent on x. All right, so once again, this variable inside the parentheses here, the whole function is going to be dependent on that variable. So this is a function of x. And this part here, b of x, that is your input function. All right, so b of x right here is going to be your input function. You will see on the charts there will be an input and an output. We'll get to that later. And finally, this capital letter outside the parentheses, that is basically going to be your output. All right, so again, you'll see the chart will have a breakdown between the input and outputs. All right, so just to rehash, this is the input variable. This whole thing is the input function, and the letter outside of the parentheses is going to be your output. Okay, Prachi, the office manager at a private practice, modeled a few relationships. All right, so you will see this chart in most of the problems. Okay, they have the inputs and the outputs here in columns and the function variables. All right, the expression L of P of T represents which of the following? Okay, and notice in all the problems it says function of something for the last half of the sentence. Function of, function of. So we want to see what this is a function of first. Remember, we said this is the input variable right here, and that's what it is a function of. So this is a function of t. And also we said this is the input variable, right? So this is a function of t. We have to see what input t represents. If we go to the inputs, t, lowercase t, is the time of day. So this whole thing is a function of t, which is time of day. I'll write that in parentheses. All right, this whole thing is a function of the time of the day. And what it gives you, the output, this is the output variable here. We have to look up capital L. Here's capital L. And here is the output column. And it gives you the average length of visit. All right, so that's what L represents. So as a result, this whole function will give you the average length of a visit as a function of the time of day. Let's take a look. Actually, one quick thing before I get to the answers. Notice the input function. I'll erase this here. Notice that the input function is P of t. All right. So you take P of t. I know it says output here because you plug in t and you get P, right? P of t, people in waiting room. But that becomes the input on the L function, okay? Because L is the output. So notice how that works. The people in the waiting room is the output at first, and then it gets plugged in for the people in the waiting room in the L function. All right, you don't have to do that part. I was just explaining it to you. But back to what we were saying, L is the output. That's the average length of a visit based on the time of day. Let's take a look. Right here, average length of a patient visit as a function of the time of day. Answer B. Raphael has a solar-powered video game console. He saw and modeled the following relationships. Okay, as always, we have our function variables in the input and output columns. By the way, I think most of the time these write-ups at the beginning are basically useless. You can read it if you want. Which two of the following composed functions make sense in this context? All right, you have to choose two answers. So let's see. E of G of R. That means we're taking G of R and plugging it into E. Let's take a look. All right, if you take the output for G of R, that's hours of video games played, and you plug it into the input of E, that's hours of daylight. Okay, you cannot take G and plug it into E, because this is hours of video games and this is hours of daylight. So E of G of R does not make sense. Therefore, A is no good. Let's see, E of D of X. We take D of X and plug it into E. All right, the output for D of X is right here. And here's E. Can we plug it into E for the input of E? Hours of daylight, that checks out. Answer B makes sense. All right, click B, moving along. D of E of K. We take E of K and plug it into D. Let's see. All right, here's E of K. Here's the D function. Here's the input for D. Can we take amount of solar energy and plug it in for the time of year? No, we cannot. Those do not match. So it is not answer C. All right. So it must be D, but let's make sure. G of E of K. We take E of K and plug it into G. All right. E of K is right here. And we're going to plug it into G. The input for G is right here. So E of K is the amount of solar energy gained. Amount of solar energy gained for the input. That checks out. They're the same. So that works. All right, B and D. Skylar climbs a watchtower to guard against forest fires. The function R of H equals radical 13H gives the distance in kilometers that Skylar can see when their eyes are H meters above the ground. The function A of D equals pi D squared gives the area in square kilometers that Skylar can guard when they can see a distance of D. Which expression models the area Skylar can guard when their eyes are H meters above the ground? Okay. So they ask, this is a wordy question, but really we're doing composite functions. So you can basically tell already what we're going to do. All right. They said this function is distance. So let me just write that above the function here if I have enough room. This right here represents distance. All right. The whole function is distance. And it says here in the follow-up function, A of D, where D represents distance. Okay, so if this is the this is the distance and D is the distance, we're going to take this function right here and plug it in place of D. All right, that's all we're going to do. And basically, A is the output, so what we are creating is A of R of H. Okay, it's a function within a function. All right, let me move this over so there's more room. All right, so A of R of H is going to be pi times D squared, but we are plugging in radical 13H in place of D. So in place of D, radical 13H. And the D is squared, so radical 13H gets squared. All right, we still have pi. And when you square something that's under the square root, you just remove the square root. So radical 13H squared is just going to be 13H. So that's basically it. Usually you put the variable last. Pi is not a variable. That's about 3.14. 13 is not a variable, but H is. So I think it's going to be 13 pi H. And that is your final answer. And what this is area, because A represents area. It's going to be area as a function of h, which is h meters above the ground. I guess that's height. So it's area as a function of height. That's all it is, 13 pi h. Which expression models the area Skylar can guard when her eyes are h meters above the ground? All right, so it's just 13 pi h. And that's it. All right, for these problems in general, you're going to take one function and plug it into the variable for the other function. That's all you're going to do. All right, last one. I'm going to ignore this right up at the beginning. We have the input and output columns as always. Which of the following expressions represents the number of ink cartridges used as a function of the minutes of morning yoga? All right, so when we write this, it's going to be a variable on the outside and a variable on the inside. Function of minutes of morning yoga, that is going to be the input variable. Okay, and what it gives you is the number of ink cartridges. That is going to be the output variable, whatever it is right here. All right, so let's first look for the input. Minutes of morning yoga is going to be the input. All right, so minutes of morning yoga, for the input, that is x. So that's going to go right there. And the output we're looking for is going to be, we said, number of ink cartridges is your output. And we can see for the output, number of ink cartridges is going to be I. So hopefully that's all we need. All right, let's take a look. And we don't need this letter. Let's make sure. I on the outside, X on the inside. Okay, so unfortunately, there's I of S of X and I of P of X. Let's see which one gets plugged in for I. It's actually pretty easy. Let's see which one gets plugged in for I. Okay, here's I. The input for I is the number of pages Burian writes. And right here is the output for P, the number of pages Burian writes. So this output gets plugged in here. So it's going to be I of P of X. Output, input. I know it looks reversed because you're plugging in X to get P of X, and then you're taking that and plugging it in here. All right, so it's going to be I of P of X. All right, so that's it. The reason why I of S of X wouldn't make sense, first of all, there is no S of X. And second of all, when you get the function, when you do the function for S, this is your output. You cannot take that and plug it into the I function. These do not match. So that's why it's not I of S of X. Plus the variable isn't even correct. We said X was the minutes of morning yoga.